Alright, directions say analyze and sketch the graph. The first thing I like to do is if I recognize any opportunities to factor polynomials, I'm going to go ahead and do that. And the numerator does not factor, but the denominator does. Denominator factors x plus 5 and x plus 2. Now I want to do that because if it were to happen that the numerator x plus 3 would cancel one of these denominator factors, I'd want to go ahead and do that, and there's something unique about the graph when that happens. But in this case, it didn't happen. But that's kind of why I want to go ahead and factor it. It's just simply I'm checking to see if that reduces. It also is going to help me find the vertical asymptote on this next step because I'm going to have to do that anyway. So let's first find the vertical asymptote. Okay, the vertical asymptote happens where the denominator, which is x plus 5 and x plus 2 equals 0. So that happens at -5 and -2. There are actually two of them on this particular graph. So a vertical is my -2, and 3, 4, 5, here's my -5. Okay, so I've got both of my vertical asymptotes in place. Now I'm going to find the horizontal asymptote. And for the horizontal asymptote, I'm going to look here at the largest power of x that I see on top and bottom. Now I notice the power of x on top is smaller than the power of x on bottom. So 1 versus a 2. So since it's smaller on top, the power is smaller on top, that means it's the line y equals 0. So that is right on the x-axis. Okay, so I've got my horizontal and my vertical asymptotes. The next thing that I'm going to do is I'm going to point plot. So what do I need? Well, I need a table of values for the numbers that are out here on the x-axis that are left of -5. Say -6, -7, -8, etc. I need a table of values for the numbers between the two asymptotes. So that would be maybe -3, -4, maybe -3.5, etc. And I also need a table of values for the numbers that are bigger than -2, like -1, 0, 1, maybe I skip out and get 5, etc. Well, that's a lot of work to do, because that's putting a lot of numbers into the x's here and then computing out their respective y values. So what I'm going to do is allow you to speed this up on the graphing calculator, and so let me show you how I would go ahead and do that. So first thing I do is I type in the function. Let's get it up here so you can see. If I can do it without the sunlight, that would be great. Okay, so we've got x, I'm going to use parentheses, x plus 3 divided by parentheses x squared plus 7x plus 10. Okay, so there it is typed in. I'm going to zoom standard, and so there we can see our function. So we can see where the curve should be. I should have a curve here, I should have one that cuts down here, and one up here. But what I want are the points. I want to plot real points. So I'm going to go into the table, which is right here on the graphing calculator. I'm going to hit second graph, get into table. Okay, so now I can come in here and I can get some of the XY points that I want out here. Okay, I can get some of these points in the middle. And maybe you don't like that because look how small these Y values are here, these negative decimals. What if I wanted to count by halves? Maybe if I count by halves here on the X, it'll be a little bit better. So I'm going to go into table set. You can see it right there above the window. I'm going to tell the table to count by halves, not by ones. Just see if that helps a little bit better. maybe a little bit. Okay, so I've got a table built. I'm going to go ahead and plot points from the table here onto my paper graph, but I'm going to put the calculator down, so I'm assuming that you're either just copying this or you're reading off of your own table to plot real points. So at -5.5, we're at negative almost 1.5. See, -6, we're at -3/4. I'm going to come out to -8, and it's about -1/4. So that's kind of enough. I like to get 3, maybe to 5 points, just so I can kind of see what the curve is doing. So I've got it there. Between my two asymptotes, looks like -4.5 is at 1.2. -4 is at half. Let's see, -3 is at 0. -2.5 is at -0.4. So it's enough to see with these points that the motion that's going on here, kind of the movement of the graph. So connecting these, we'll get right through there. About like that. And then finally I'm going to grab some numbers on the other side of that asymptote. -1.5 is about 0.8, and then they just get smaller from there. A half is about 1/4. Oops, that would be over here. But really, I mean, they just get smaller as I come out, so that's enough for me to know that it's coming really close to the asymptote here. And then gets smaller as it goes out to the right. Remember, it cannot cross beneath the asymptote, it just needs to get closer to it as you go out to the right. So there's our graph. It's what this kind of shows here anyway. But here it is on paper. Next problem has the same directions. I'm going to begin by factoring where I see the opportunity to factor. That would be x plus 3, x minus 1 over x minus 2. Nothing canceled, so it didn't really get me anywhere there. But again, I did it because I wanted to check to see a vertical asymptote. Oh, again, remember, for the vertical asymptote, you are checking the denominator. X minus 2 equal to 0 solves to give 2. So at x equals 2, we've got a vertical. And now for the horizontal, we're looking at the powers of x on top and bottom. And notice that I have an x squared on top and an x to the first on bottom, so it's bigger on top than on bottom. So this means there's none. There is actually a slant asymptote. Like somewhere there's a slant asymptote coming through here, which would bound the movement of the graph, and I'm not going to go over how to find that, at least at this point in the course. But that's what's really happening in that instance. So we're not going to draw any horizontal asymptote on this graph. What I'm going to do now is just simply do some point plotting again. So I need a table of values for the numbers out here, a table of values for the numbers out here. I'm not going to, again, make real tables. I'm going to do it all on the graphing calculator. So let's see. I'm going to clear out my old one, and so here we go. We've got, always use parentheses, x squared plus 2x minus 3 divided by x minus 2. I'm going to graph it just because I want to see what this looks like. Yep, so I can see my vertical asymptote right here at 2. It looks like the other branch is probably way up here off the graph. Let's see if I window out and make that go out to say 20, and maybe make it go up to positive 20. Do we see the other part of that? And yeah, we do. So it's up there. It was just off the original window settings of the graph. But let's now go into table and let's plot some points that show up here. So I've got Let's see, there's an easy one. -8, -4.5. Okay, I've got, it looks like -6 is about -2.5. -3 is at 0. Let's see, 0 is at 1.5. See, 1 is at 0. So now I can kind of see the form of this. Okay, so investigating on the graph, get a picture of the graph so you know what you're trying to draw. Okay, so begin here, get the picture, go into table, plot enough points so that you can smoothly draw on paper what this is showing here. And since my grid, I can't change the window on my grid, I'm not going to window out and see this one that's curving up here. I'm just going to show what I can show.